How's it going, Algebra 1? It's Mr. Knight, and we are going to have kind of a shorter lesson today. Really, I just kind of want to pump the brakes a little bit and look at these three monomial rules that we've explored so far. So on your notes, you should definitely copy down this chart, and we're going to look to add on to it later on in the week. But this is really just building up to when you guys come back on. It'll be Tuesday and Wednesday to get some additional practice with all this stuff, because I think like in isolation these rules aren't too bad, but when you start putting them all together, that's where you can run into some trouble. And so let's talk about that stuff and kind of hopefully alleviate some of the issues you're having. So the three rules we've gone over adding and subtracting monomials, and we'll start there. It's a good place to start because it's the most familiar we have with these. The whole rule with it is to just combine like terms. And when you add these guys or subtract them, you are just going to be looking at their coefficients, basically. Okay. Remember, coefficients are like the numbers that are out in front. So like for these examples, it'd be like this guy and this guy. It could also be this 6 and this 8. Those guys would be the coefficients. And we're not going to change the variables or exponents when we add and subtract. We don't have to do that at all. Okay. So for this example, number 1, they are like terms. They have the same variables, same exponents. Both are x squared y. So we just do 9 minus 10, and we get negative 1 out of that. So it would be negative 1 x squared y would be our answer. Looking at number 2, it's a word problem, kind of. It says subtract 6w from 8w. That from is indicating that that number or that monomial is coming first. So it'll be 8w, and we're going to subtract 6w off that. Once again, they are like terms. They both just share w. So it's 8 minus 6, and you get 2w. Okay. Next is the product rule. This is when you end up actually multiplying your monomials, hence product, right? So if you have something like x to the a power times x to the b power, if you want to combine those monomials, then all you have to do is take those exponents and you're going to add them together. It'll be x to the a plus b power. So looking at number 3, it's h to the second times h to the 6, and so we're going to do h to the 2 plus 6, so we get h to the 8th power. All right. Something might be a little bit more complicated with like number 4. Once again, we still can look at each of these variables and we can add their exponents. So I'm looking at my a's. This is a to the second times a to the third, so it'd just be a to the 2 plus 3. So that's a to the 5th. And then this is b to the first times b to the first. So 1 plus 1, we get b to the 2nd power. Now, when it comes to your actual coefficients, we are actually going to multiply those guys. That's when we actually do the multiplication. So we're going to do negative 2 times 7, and we get negative 14 out of that. It's a little out of order than what we did on your notes, but you still arrive to the same result regardless. Multiplication, like I said, you can flip-flop it. So it's okay if we went a little bit out of order because it's all being multiplied anyway. So just breaking it up piece by piece. The power rule, this is when we have something like x to the a, and then it's raised to another power. Okay, this is where we need to actually multiply those guys together to combine them, so we get x to the a times b, just like that. So looking at this one, x to the 2nd power raised to the 3rd power, that's x to the 2 times 3, which is x to the 6th power. All right. And once again, when it comes to working with coefficients, like this is the power rule, so we're going to have to raise our coefficient to a power. When we had the product rule, we had to multiply our coefficients, hence product. When we added and subtracted our monomials, we added and subtracted the coefficients. So the coefficients are always doing what the operation wants it to do. It's where the exponents have the additional rule. That's where things can get a little confusing. So as long as you remember these rules and how they just apply with your exponents and variables, you won't run into many problems. Okay? Let's start with them for this example. So notice we have the power rule that we could use, and we could also multiply. So we're going to have to actually multiply our exponents, and then we're going to have to end up adding our exponents here. So this is going to be m to the 5 times 2 power, so it's m to the 10th times m to the 3rd. And let's go ahead, let's take care of that coefficient. It's going to be negative 2 to the 2nd power. You raise your coefficient to the power, okay? And so negative 2 to the 2nd power is just a positive 4. Got to keep our signs in mind. Positive 4 m to the 10th times m to the 3rd. And then we can go ahead, because this is multiplication, we can add our exponents and get 4m to the 13th power. Okay. So we're going to look over 3 examples that incorporate a mixed bag of all of these rules and kind of see how we work them out. A good rule of thumb is to apply PEMDAS to this, not SADMAP. SADMAP was when we were doing equations. We are only just working with expressions. There's no equations. So if it helps you, remember PEMDAS, and that's the order of operations that you'll use in order to do this. Okay. So if we look at this, we work with the parentheses first. Nothing we can do. Exponents. There's no power rule to apply. There's no outer exponent out here, so we don't have to do anything with that. And then it comes to multiplying, which we clearly can. We can multiply, and we'll multiply this piece first before we go ahead and subtract. All right. So again, coefficients will actually multiply. 10 times 3 is 30. The variables and their exponents, they will add because of the product rule above. So a to the 4th times a to the 5th is a to the 9th. And then b is going to go to the 8th power. 6 plus 2 is 8. Okay, so that whole piece turned into that, simplified it. And then we're going to look to subtract the 7a to the 9th, b to the 8th. And you look and you say, are they like terms? Do they have the same variables and exponents? And yes, they do. Okay, so that's good. So all we have to do now is do 30 minus 7 and get 23. And it would be 23 a to the 9th, b to the 8th. Remember, adding, subtracting does not change our variables or exponents. That's what our rule tells us. Okay, so that would be our final answer. We can't do anything else with that. Okay. Let's look at 2 more. Let's look at this one above right here. Okay. So once again, we look and we go through PEMDAS and we think, okay, are we doing parentheses? Well, yeah, but we can't do anything with it. Exponents. Any exponents on the outside? Yes, we got the power rule that we can actually apply. We have this dangling exponent. Okay. So let's go ahead. Let's take care of that. So when it comes to multiple exponents, you can think about it too, and it's kind of been hidden. It's been kind of hidden in the background, but basically what I'm doing with like the power rule is I'm taking this outer exponent and I'm applying it or distributing it to pretty much the exponents of each part of my monomial, so the coefficients in each variable. So I'm going to take this 2 and I'm going to distribute it, which means multiply, to each of these guys, their exponents right here, right? I'm not doing negative 5 times 2. I'm doing negative 5 to the 1st power times 2, right? The first, because this is a power rule, the 1 and the 2 are going to multiply. So this is negative 5 to the 2nd power. Negative 5 times negative 5 is a positive 25. X to the 4th times the 2nd power, that's going to be x to the 8th. Because you're multiplying, and this guy's going to be y to the 14th. All right. Then we can go ahead, we can add the 9x to the 8th, y to the 14th, and once again, these guys are like terms, so I just have to do 25 plus 9, I end up getting 34, and it'd be 34x to the 8th, y to the 14th. Those don't change. And for our final example, we have, it looks like the power rule that we got to apply again. And then it looks like we have multiplication right here in the middle after. Looks like we don't have to add at all. Okay. So let's go ahead, let's apply the power rule. Once again, if there's nothing, if there's like no exponent showing up, it's implied. It's just to the 1st power for each of these. So if you want to write the 1 in there to help you, you can. and you can once again treat it just like distribution of the exponent. Negative 2 to the fourth, that's negative 2 times negative 2. Okay, so that's a positive 4. Times negative 2 is negative 8. Times negative 2 is a positive 16. Okay, 16, x to the fourth, y to the fourth. And then let's apply the power rule here. Negative 3 to the third power. That's negative 3 times negative 3. So that's positive 9. Times negative 3 is a negative 27. Okay? And then it's going to be x to the, because we're distributing, it's going to be x to the 6th power. Alright? Now we look to multiply these guys. Well, you got to do 16 times negative 27. I have no idea what that is off the top of my head, but that's why we use calculators. They can help us. 16 times negative 27. Oops, I messed up. 16 times negative 27. I end up with negative 432. Obviously, right? Duh. Okay. And then these exponents, okay, because we are multiplying our monomials, these guys are going to do what? They are going to add, because our product rule tells us we add the exponents for like bases. So this is x to the 4 plus 6, x to the 10th, and this is still just going to be y to the 4th, because it's still there, it still counts. And that is our final answer. Alright, this is Mr. Knight signing out. Hope you have a good day.